Examining the deepest strata of continental rock reveals a world separated from ours by 252 million years. Geologists piecing together these mineral clues do not find a chaotic wasteland. They uncover a masterpiece of biological and chemical equilibrium. Decoding ancient zircon crystals and measuring isotopic signatures requires a leap of human intellect, allowing us to vividly reconstruct a vanished reality from microscopic fragments. Long before any dinosaur walked the Earth, our planet operated under a different yet functional set of rules. Land masses had converged into a single supercontinent known as Pangaea. Spanning from pole to pole, this monolithic terrain dictated global weather patterns, governed atmospheric currents, and shaped the evolutionary pathways of countless species. To comprehend this era is to marvel at the sheer analytical power of modern science, which bridges a gap of 250 million years to show us an Earth operating at peak ecological capacity. Imagine a planetary archive functioning with precision. Every biological niche represents a carefully curated shelf, while every chemical exchange acts as an updated record. Rivers carve through the arid continental interior as precise filing systems, transporting vital nutrients where needed. Coastal margins hold dense forests of seed ferns and giant horsetails, efficiently pulling atmospheric carbon down into the soil to be permanently bound. Nothing goes to waste within this biological registry. Chemical transactions between the air, the terrestrial landscape, and the single global ocean balance perfectly within a grand, invisible ledger. Solar radiation entering the atmosphere matches the thermal energy radiating back into the cold vacuum of space. Carbon dioxide exhaled by ancient fauna or vented by mild, regular tectonic activity is immediately sequestered by vast green expanses spreading across the temperate zones. Nature operates a flawless accounting firm where every metabolic function is recorded, processed, and ultimately resolved. The synapsids roam this organized library. These creatures represent an evolutionary marvel, standing as the undisputed rulers of the Permian period. Paleontologists tracing their fossilized remains uncover brilliant anatomical adaptations that will eventually lay the groundwork for modern mammals. Synapsids are not sluggish, primitive reptiles dragging their bellies across the dust. Many possess upright postures, allowing for efficient locomotion across vast distances. They display complex, differentiated teeth designed for specialized chewing, replacing the simple tearing mechanics of earlier lineages. Scientific deduction points toward early forms of endothermic temperature regulation, allowing these animals to thrive in diverse microclimates across the vast Pangaean landmass. Saber-toothed gorgonopsians patrol the extensive floodplains as apex predators. Their large skulls and powerfully engineered jaws demonstrate a level of biomechanical perfection optimized for swift, decisive hunts. As they track prey across seasonal wetlands, these hunters maintain the population balance of the lower trophic levels. Below them in the food web, bulky herbivorous dicynodonts graze across endless verdant valleys. Burrowing species relentlessly churn the soil, aerating the ground and contributing to a dynamic, living terrestrial engine. Every animal plays a distinct, irreplaceable role in maintaining the broader biome. Elaborate symbiotic relationships flourish, turning the supercontinent into an integrated organism where energy flows seamlessly from plants to herbivores and finally to apex carnivores. Panthalassa lies surrounding the singular continent, encompassing over 70% of the globe. This colossal body of water functions as the primary climate regulator. Understanding its ancient mechanics highlights our modern grasp of fluid dynamics and thermodynamics. Deep ocean currents trace predictable geometric paths, driven by clear temperature gradients between the equator and the poles. Surface waters absorb oxygen from the atmosphere and transport it down into the abyssal depths through steady thermohaline circulation. This mechanical sinking of cold, dense water sustains rich marine ecosystems miles below the sunlit waves. Coral reefs built by ancient sponges and intricate brachiopods span the shallow continental shelves, creating vibrant underwater cities. Ammonites with mathematically perfect coiled shells navigate the mid-water columns, capturing smaller prey with coordinated precision. Marine life thrives in a state of continuous, reliable prosperity. Seasonal monsoons sweep across the coastal regions of Pangaea on strict mathematical schedules, delivering life-giving rains to parched interiors before retreating. The rhythm of the globe pulses with mechanical regularity, governed by atmospheric pressures and oceanic temperatures that rarely deviate from their historical baselines. A close look at the broader carbon cycle of this epoch reveals a masterclass in elemental harmony. Oxygen levels support vigorous, high-energy life forms across diverse altitudes. Greenhouse gases exist in the right concentrations to keep the planet warm and liquid without triggering runaway heating. Microscopic phytoplankton floating in the sunlit layers of Panthalassa draw down dissolved carbon dioxide to build their cellular structures. When they eventually die, they drift downward like gentle marine snow, burying raw carbon securely in the ocean floor sediment. Terrestrial forests perform the same function on land. Fungi and industrious detritivores break down fallen timber, releasing just enough nutrients back into the soil to fuel the next generation of growth, while trapping the excess carbon beneath layers of peat. We see a closed loop functioning flawlessly. Earth processes heavy elements and volatile gases with the quiet efficiency of a well-oiled machine. Generations of flora and fauna rise and fall over millions of years within this stable framework. Evolution shapes intricate behavioral patterns based on the assumption that tomorrow will operate like yesterday. Specialized insects develop specific mouthparts to feed on particular plant structures, tying their genetic destiny to a single floral host. Predators evolve hunting strategies dependent on the predictable migratory routes of their prey. To an advanced observer calculating the planetary metrics of the late Permian, this world appears invincible. The ecosystem has weathered minor environmental fluctuations over millions of years and emerged stronger, more diversified, and more efficient each time. Biological diversity continues to expand outward, pushing resilient life forms into harsher deserts and deeper oceanic trenches. Success inevitably breeds deep genetic specialization. Creatures become tuned to very narrow temperature ranges and specific atmospheric pressures. They invest all their evolutionary capital into the reigning environmental paradigm, optimizing their bodies for the conditions of the present moment. Nature archives its most successful blueprints, assuming the foundational rules of the planet are fixed. Such profound stability creates a powerful, compelling illusion. When ecological and chemical systems operate without significant disruption for countless millennia, permanence feels absolute. The vast planetary archive seems permanently sealed against catastrophic data loss. Mountains rise slowly through measured tectonic pressure while steady erosion grinds them down at an equal, balancing pace. The global silicate weathering thermostat maintains a steady baseline temperature, naturally adjusting to any minor spikes in atmospheric carbon. Every measurable biological indicator points toward an endless horizon of continued prosperity. Synapsids continue to branch out, exploring new physical forms, expanded sensory capabilities, and complex social behaviors. Humanity looks back at this flourishing chapter of deep time and recognizes a vibrant, bustling Earth operating at peak capacity. We admire the intricate biological machinery that governed the Permian landscape. We understand how the climate maintained its delicate, life-sustaining equilibrium. Yet, reading the geological strata further up the rock column reveals a profound truth about optimized complex systems. Ecological efficiency often requires sacrificing broader environmental resilience. Perfectly balanced equations remain stable only as long as the underlying variables remain constant. Deep beneath the continental crust, far below the vibrant ancient forests and sunlit hunting grounds, Foundational rock layers hold restless geothermal energy, waiting for a microscopic shift in the planetary baseline. The ledger of life continues to record its daily transactions, unaware that the physical vault housing its curated records rests upon a boundary about to be fundamentally rewritten. Modern geologists must journey to the remote, freezing expanses of contemporary Siberia to trace the origin of this rewrite. While traversing this harsh terrain today, researchers uncover immense terraced rock formations stretching across millions of square kilometers. Mapping these colossal structures reveals a story etched not in sudden violence, but in relentless geological endurance. We call this expansive region the Siberian Traps. Deciphering its deep origins stands as a monumental triumph of human ingenuity. By utilizing advanced radiometric dating and deep seismic imaging, scientists successfully peer through solid stone to reconstruct the anatomy of a continent-sized rupture. Far beneath the rigid crust of ancient Pangaea, an unusually large upwelling of superheated rock began to detach from the extreme depths where the solid lower mantle meets the liquid outer core. Rising with agonizing slowness through the interior of the Earth over millions of years, this mantle plume possessed vast thermal mass. It eventually pressed against the underside of the continental lithosphere, steadily transferring heat and softening the tectonic plate from below. Surface landscapes above gave no immediate warning of the shifting thermal dynamics. Animals continued their established migratory routes, and dense forests thrived directly above the warming rock. Deep underground, however, intense decompression melting generated colossal volumes of liquid basaltic magma. Subterranean chambers spanning entire latitudes steadily filled with highly pressurized molten material. Rather than culminating in a single, conical mountain blowing its top in a brief cinematic display, the continental crust simply stretched until it reached a breaking point. Wide linear fissures, some extending continuously for hundreds of miles, tore open across the diverse topography. Superheated liquid rock spilled directly from the deep mantle onto the terrestrial plains. Exceptionally hot and possessing very low viscosity, this highly mobile lava did not build steep volcanic peaks. It flowed outward in vast, relentless horizontal sheets, seeking low ground and filling entire river valleys with a glowing tide of deep earth material. To capture the sheer magnitude of this geological event demands a profound shift in our standard understanding of time and physical scale. Rivers of molten basalt poured from the fractured ground not just for days or seasons, but continuously for roughly 1 million years, pulsing relentlessly from the open terrestrial wounds. Overlapping waves of liquid rock effectively paved over an area roughly equivalent to the entire modern continental United States. Stratigraphic records show that in some central locations, the accumulated magma reached astonishing depths exceeding 2 miles. Humanity maps these hardened, stacked layers today, identifying distinct eruptive pulses separated by incredibly brief geological pauses. The total volume of extruded material pushes the outer boundaries of human comprehension, confirming this geological anomaly as one of the most extensive volcanic outpourings in the known history of the planet. We can accurately picture the mechanics of this protracted event by envisioning a slow leak in a sealed room. An imperceptible drip rarely commands immediate attention or triggers an emergency response. Localized terrestrial ecosystems directly in the path of the encroaching magma naturally perished under the extreme heat, but the wider supercontinent easily absorbed this localized loss. Mobile life forms migrating away from the advancing basalt fronts merely relocated to neighboring regions, assuming they could find new niches. The primary danger did not stem from rapid, sweeping destruction, but from the inescapable, accumulating nature of the continuous intrusion. A slow leak gradually and systematically alters the foundational baseline of an enclosed environment. It introduces a persistent, physical variable, that cannot be neutralized by the existing defensive mechanisms of the room. Year after year, century after century, the sprawling terrestrial fissures continued to bleed large volumes of mantle material, steadily raising the localized baseline temperature of the surrounding crust and fundamentally overwriting the regional topography. Analyzing the crystalline structure of the cooled basalt provides essential data regarding the fluid dynamics of the ancient magma. Formed under highly specific cooling conditions, hexagonal columns crystallized as the thick lava sheets contracted and solidified over centuries. Modern geoscientists exploring these precise geometric pillars today can reverse engineer the thermal gradients of the erupting rock with incredible accuracy. Measuring the radioactive decay of uranium isotopes into lead within microscopic zircon crystals trapped securely inside the solid basalt grants us an impossibly precise chronological timeline. This brilliant analytical capability allows researchers to match the duration of the magma flow with subtle shifts occurring simultaneously in the global fossil record. Discovering these correlations requires decades of meticulous, grueling fieldwork and sophisticated laboratory analysis, representing a pinnacle of collective scientific deduction. By successfully interrogating these weathered stones, researchers transform dormant, frozen landscapes into actively speaking historical testimonies. Expanding our observational view from the immediate lava plains to the wider global biosphere reveals a deeply fascinating scientific discrepancy. If the sheer physical volume of extruded rock were the only variable at play, the global ecosystem possessed more than enough resilience to adapt. Earth has confidently endured other flood basalt eruptions throughout its vast, deep history, without suffering total ecological resets. Burning forests and vanishing habitats in the immediate vicinity of a massive rupture represent a severe regional disruption, yet they lack the necessary mechanical reach to dismantle life on a planetary scale. Continental flora and fauna hold remarkable evolutionary resilience, fully capable of steadily recolonizing devastated zones once the molten rock cools and begins weathering into fertile soil. The physical lava, despite its terrifying magnitude, large volume, and extreme heat, remained incredibly limited by its strictly geographical boundaries. Molten rock cannot physically traverse vast open oceans, nor can it blanket an entire supercontinent solely through its own lateral spread. Uncovering the true nature of this continental anomaly requires us to look far beyond the glowing rock itself. The expansive basalt flows served merely as a brilliant thermal engine, acting as a physical catalyst, initiating a much darker, fundamentally different reaction. A deep look beneath the hardened lava reveals the unique chemical composition of the specific crustal region the magma had to pierce. Long before the rising mantle upwelling tore the ground apart, this particular sector of ancient Pangaea housed vast subterranean basins filled with thick, sedimentary rock. Millions of years of prior biological and geological activity had heavily deposited vast reserves of ancient carbon, organic coal, volatile oil, and mineral-rich evaporites deep underground. Rising magma operates as a primary chemical solvent and thermal trigger when directly interacting with such volatile, rich, sedimentary layers. As it journeyed upward from the deep mantle, the superheated rock essentially baked the continental crust from the inside out, long before it ever breached the surface. Direct contact between highly pressurized liquid basalt and subterranean coal beds ignited colossal underground fires that raged unseen for millennia beneath the earth. Complex hydrocarbons locked away safely for countless eons suddenly encountered temperatures exceeding 1,000 degrees Celsius. This enormous subterranean crucible rapidly transformed stable geological formations into an intensely active planetary furnace. The glowing rivers of lava continuously spilling across the terrestrial plains were visually spectacular, but they functioned as an elaborate physical distraction from the silent, efficient alchemy occurring directly beneath them. Realizing the massive implications of this specific crustal composition profoundly elevates our modern understanding of planetary mechanics. Thermal energy, forcefully breaking stable chemical bonds deep underground, naturally generates an entirely different class of geological threat. Gas molecules synthesized in this subterranean reaction possessed an insidious capability lacking in the heavy, localized, slow-moving lava. Highly energized particles could easily bypass solid physical barriers, slipping effortlessly through thousands of microscopic cracks and thermal vents to reach the open sky. While the physical basalt rapidly cooled, thickened, and halted upon encountering the frigid surface air, the chemical byproducts of the extensive underground combustion remained unconstrained by terrestrial friction. Grasping the precise sequence of events transforming the Siberian traps from a regional volcanic anomaly into an unstoppable global mechanism stands as one of geology's greatest investigative achievements. We look at the frozen, sweeping basaltic steppes today and clearly see the immense fossilized remnants of a grand thermal key unlocking a tightly sealed geological door. The endless surface fissures continually bleeding deep mantle material onto the land merely provided the necessary sustained heat to permanently destabilize an ancient, hidden carbon reservoir. Tracing the undeniable trajectory of these newly liberated elements points away from the solid ground and directly up into the moving atmospheric currents overhead. The physical rupture had successfully breached the deep planetary containment, allowing a silent, highly volatile, and invisible element to begin slipping quietly into the global atmosphere, setting the physical stage for a rewriting of the world's chemical operating system. Molecules of carbon dioxide and methane lack visual presence, yet they dictate the thermal architecture of our entire planet. Up until this geological juncture, the atmosphere had maintained a strictly regulated inventory of these greenhouse gases, continuously cycling them through living tissues, deep ocean currents, and weathering rocks. Piercing the crust changed this dynamic instantly. Billions of tons of pressurized gas, liberated from the ancient coal beds and volatile rich shales beneath Siberia, surged upward through newly formed thermal vents. We cannot see these ancient plumes with our eyes, but modern paleoclimatologists track their precise movements using remarkably sophisticated isotopic analysis. By examining microscopic marine shells and deeply buried sedimentary layers across the globe, researchers consistently detect a massive, sudden spike in carbon-12. Living plants preferentially absorb this lighter isotope during photosynthesis, ultimately storing it deep underground over millions of years. Discovering a sudden global flood of carbon-12 in the rock record provides indisputable mathematical proof that subterranean organic reservoirs were rapidly vaporized and injected straight into the late Permian sky. Measuring this isotopic excursion requires instruments of astonishing precision. Mass spectrometers, employed by modern laboratories, bombard ancient rock samples with electrons, separating individual atoms based on microscopic differences in mass. Isolating these distinct elemental signatures allows humanity to reconstruct the chemical composition of an atmosphere that vanished 250 million years ago. Such deductive reasoning showcases the profound capability of the human mind to render the invisible visible. We do not merely guess at the conditions of the past. We actively decode the structural geometry of ancient molecules embedded within solid stone. Injecting such astronomical volumes of carbon into the sky fundamentally altered the way Earth processed incoming solar energy. Sunlight passing through the upper atmosphere consists primarily of shortwave visible light, which strikes the terrestrial surface and warms the ground. Radiating back upward, this energy transforms into long-wave infrared radiation. Normal atmospheric compositions allow the vast majority of this heat to escape harmlessly into the freezing vacuum of space. Carbon dioxide and methane, however, possess specific atomic structures highly responsive to infrared frequencies. When outbound thermal radiation encounters one of these complex molecules, the energy is absorbed, causing the molecular bonds to vibrate wildly before re-emitting the heat in all directions. Bouncing back toward the surface, this trapped energy fundamentally shifts the thermodynamic balance of the entire globe. To understand the sheer scale of this carbon injection requires us to visualize an immense, invisible thickening of the global atmosphere. Trillions of microscopic molecular reflectors rapidly accumulated above the continents and oceans. Among these rising gases, deep Earth methane played a uniquely devastating role. Possessing an atomic structure far more efficient at trapping heat than carbon dioxide, methane acts as an aggressive thermal multiplier. Vast quantities of this volatile gas, previously locked securely within subterranean geological traps or frozen deep within coastal continental shelves, expanded rapidly under the intense geothermal heat of the Siberian intrusions. Upon reaching the surface, these energized molecules dispersed rapidly across the latitudes on high-altitude wind currents. Within a remarkably short geological time frame, the atmospheric geometry of Pangaea was rewritten. Yet, standing on the expansive floodplains during the early stages of this event, an observer would notice no immediate visual change. Synapsids continued to hunt beneath perfectly clear, sunlit skies. Dicynodonts grazed on lush ferns, unaware that the physical rules governing their existence had already shifted beneath them. The sky did not immediately darken, nor did the air turn instantly toxic. Instead, the lethal nature of this chemical transition lay in its mathematical subtlety. Trapping slightly more heat than the planet could expel each day initiated a quiet, compounding thermal buildup. Biological systems operate primarily on specific tolerances. Evolution molds creatures over countless millennia to thrive within extremely narrow margins of temperature and atmospheric pressure. Permian fauna had successfully optimized their anatomies for the deeply entrenched conditions of their stable era. Their respiratory systems, cellular metabolism, and reproductive cycles were all intricately calibrated to a baseline that no longer existed. When the atmospheric heat retention began its steady climb, these magnificent evolutionary adaptations suddenly transformed into fatal liabilities. Consider the efficient thermoregulation developed by the dominant predators of the age. Gorgonopsians possessed advanced metabolisms capable of generating internal heat, allowing them to remain active during cool nights and seasonal transitions. Such biological engineering requires immense energy and operates flawlessly only when the external environment allows for adequate thermal dissipation. As global temperatures marched upward, driven by the thickening molecular blanket overhead, these apex hunters gradually lost their ability to shed excess body heat. Their specialized biological engines, designed to retain warmth, began to overheat catastrophically. The very anatomical advantages that had secured their position at the pinnacle of the food web now accelerated their physiological collapse. Terrestrial flora faced a similarly inescapable mechanical failure. Broad-leafed ferns and towering seed trees relied on tiny pores called stomata to inhale carbon dioxide for photosynthesis, while simultaneously regulating water loss through transpiration. Thriving in an atmosphere suddenly saturated with excess carbon, these plants naturally reduced the density of their stomata to optimize gas exchange. However, this microscopic, anatomical adjustment drastically diminished their ability to pull water up from their root systems to cool their external tissues. Bombarded by steadily increasing ambient temperatures, the vast terrestrial forests essentially lost their internal fluid transport mechanics. Without the ability to effectively sweat, sprawling canopies began to wither under the intensifying, inescapable ambient heat. Observing this gradual biological desiccation reveals a stark, deeply fascinating truth about the nature of survival. Extinction does not always arrive through sudden impact or dramatic terrestrial upheaval. It often unfolds as a silent, mathematical decoupling between living organisms and their chemical environment. The Permian creatures did not fail through any genetic inferiority. They were spectacularly designed, complex, and capable organisms. Their eventual demise simply illustrates the impartiality of planetary physics. When the chemical variables of an environment change rapidly enough, millions of years of evolutionary refinement are rendered obsolete. Tracking the global dispersion of these invisible greenhouse gases further highlights the profound interconnectedness of planetary systems. High-altitude jet streams and massive convection cells rapidly distributed the thermal energy far beyond the initial site of the Siberian anomaly. Expanding thermal zones pushed steadily outward from the equator, gradually consuming the temperate latitudes. Regions previously defined by distinct, predictable seasons transitioned into zones of persistent, unyielding heat. Rivers that once flowed reliably through the arid continental interiors began to evaporate faster than they could be replenished by the increasingly erratic hydrological cycle. The supercontinent, once characterized by diverse, specialized microclimates, slowly homogenized under a uniform, expanding blanket of trapped solar radiation. Geochemists studying ancient sediment cores find no evidence of massive planetary panic. Instead, the data reveals a slow, systematic dismantling of a complex biological hierarchy. Herbivore populations gradually dwindled as their highly specific food sources succumbed to the shifting thermal zones. Predators, relying on the stable availability of these grazing herds, found their hunting grounds devoid of sufficient caloric energy to sustain their large, high-performance bodies. Each subsequent generation faced a slightly harsher reality, forced to expend greater energy merely to survive in a world growing perpetually warmer. Documenting this transition from a flourishing supercontinent to a thermally stressed landscape demands our utmost intellectual respect. Modern science allows us to stand millions of years later and comprehend the physical mechanics that undid the reigning kings of the Permian. We understand precisely how carbon atoms vibrate, how heat distributes across global wind patterns, and how specialized proteins denature when subjected to sustained thermal stress. Piecing together this ancient planetary puzzle requires an unparalleled collective effort, spanning decades of rigorous analytical observation. We map the unseen currents of ancient gases with absolute confidence, translating minute shifts in isotopic ratios into a comprehensive understanding of global atmospheric dynamics. As the terrestrial ecosystems began their slow, inevitable fragmentation under the accumulating thermal load, the true scale of the crisis had yet to fully materialize. While the enormous landmass of Pangaea absorbed the brunt of the immediate atmospheric warming, an even more profound disruption was steadily building beyond the coastlines. Terrestrial life, despite its vast diversity, represents only a fraction of the global biological mass. The overwhelming majority of the planetary heat sink lies within the circulating waters of Panthalassa. Unseen by the struggling terrestrial fauna, the invisible accumulation of greenhouse gases was systematically transferring vast amounts of newly trapped thermal energy directly into the upper layers of the global ocean, preparing to dismantle the fluid mechanics of the deep. Before the oceans could fully register this massive influx of kinetic energy, the atmosphere itself had to complete a structural transformation. Translating exactly how this planetary shift operated requires us to envision an immense glass structure stretching across the globe. Radiant solar energy continuously penetrates transparent atmospheric barriers, striking the soil and rock below. Warmed by these incoming rays, terrestrial surfaces naturally attempt to radiate excess heat back outward as infrared light. However, newly introduced carbon and methane molecules acted precisely like rigid glass panels equipped with welded shut vents. High-energy visible light passed through effortlessly, while longer, lower-energy infrared waves striking the molecular ceiling bounced directly back toward the ground, generating an inescapable feedback loop. the sky ceased functioning as a dynamic thermal regulator and transformed into a closed insulator. Modeling this specific thermal dynamic stands as a monumental achievement in contemporary atmospheric physics. Researchers utilizing advanced supercomputers can simulate how trapped photons bounce between the planetary surface and the invisible molecular barrier overhead. We understand today that heat does not merely exist as an abstract concept, but manifests as vibrating kinetic energy operating at the atomic level. Trapping this energy forces every molecule in the lower atmosphere to accelerate, increasing friction and raising ambient temperatures with mathematical certainty. Such a steady, brutal climb in global heat operated without any conscious malice or localized point of origin. Physics dictates unconditionally that once escape vents are permanently sealed, internal temperatures must continuously rise until a new, far more extreme equilibrium is attained. Humanity reconstructs this invisible architecture to grasp how elemental forces govern our world. High latitudes previously guarded by vast expanses of ancient ice experienced the most dramatic initial transformations. Glaciers act as efficient planetary mirrors, reflecting a significant portion of incoming solar radiation harmlessly back into space. Deflecting this light maintains delicate planetary albedo, serving as a crucial stabilizing mechanism for the broader global climate. Driven by relentless atmospheric heat accumulation, these large frozen reservoirs began a rapid, systematic retreat. Dissolving ancient ice sheets poured immense volumes of fresh water directly into marine environments, fundamentally altering coastal topographies worldwide. Uncovering dark rock and soil previously hidden beneath the frost triggered a secondary, potent feedback mechanism. Dark terrestrial surfaces absorb solar radiation far more efficiently than pristine white ice, causing newly exposed polar lands to actively generate even more localized heat. Geologists mapping high-latitude sedimentary layers accurately detect this profound transition, marveling at the interlocking nature of planetary defense systems and their rapid cascading failures. Closer to the equator, accumulating thermal weight engineered an entirely different class of biome restructuring. Tropical latitudes normally harbor exceptional concentrations of biodiversity, thriving in consistent warmth and abundant moisture. Exceeding specific thermal thresholds, however, fundamentally alters how biologically viable these regions remain. Climatologists calculate a metric known as the wet bulb temperature, representing the point where ambient heat combined with high humidity prevents biological organisms from cooling themselves through evaporation. Crossing this rigorous physical boundary transformed the once vibrant equatorial belt into a vast, uninhabitable thermal dead zone. Expanding steadily outward from Pangaea's continental center, this lethal barrier pushed blindly across varying latitudes. Cellular machinery simply cannot operate when surrounding environments surpass strict protein stability limits. Recognizing this absolute physical limitation allows modern scientists to map geographical boundaries for this expanding void, highlighting the fragile biomechanical tolerances underlying complex organic life. Forcing terrestrial life outward, the widening equatorial dead zone initiated a desperate migration toward the poles. Animals historically anchored to specific hunting grounds or grazing territories found themselves retreating constantly ahead of the creeping thermal front, compressing millions of diverse species into rapidly shrinking habitable bands along extreme polar fringes generated unprecedented ecological friction. Herbivores competing for steadily diminishing food sources rapidly exhausted remaining vegetation. Predators crowding into these dense, overlapping territories disrupted established hierarchies, accelerating available prey depletion. We observe these dense fossil clusters today and recognize them not as thriving communities, but as final, concentrated refuges where a highly evolved biosphere simply ran out of physical space. Unraveling these complex migratory patterns requires paleontologists to act as deep-time detectives, meticulously tracking bone beds across tectonic plates to reconstruct the geometry of survival and retreat. Vegetation anchored firmly to the soil lacked essential mobility to outrun shifting climate zones. Subjected to the inescapable thermal weight pressing down from an altered sky, vast forests endured a slow systemic shutdown. Withering leaves and dying root systems could no longer maintain crucial biological pumping mechanisms required to draw moisture from increasingly parched earth. Dehydrating landscapes lost their structural integrity, leading to massive soil erosion that systematically stripped continents of their fertile top layers. Fungi and detritivores, previously operating as efficient recyclers within the ecosystem, suddenly faced an overwhelming abundance of decaying organic matter. As they multiplied rapidly to consume fallen timber, these organisms expelled even more carbon dioxide back into the saturated atmosphere, adding yet another layer to the accelerating greenhouse engine. Ancient pollen records trapped in sedimentary rock give humanity a precise, high-definition view of this botanical transition, proving our exceptional capacity to read microscopic testimonies left by vanished flora. Investigating how the terrestrial biosphere collapsed requires us to zoom past broader ecological migrations directly into the microscopic realm of cellular biology. Sustained heat effectively functions as a mechanical solvent, systematically dismantling living tissue's highly ordered structures. Essential enzymes responsible for digesting food, repairing DNA strands, and transmitting neurological signals begin to denature and unfold when subjected to extreme ambient temperatures. The observation of this systemic failure reveals a deeply fascinating mechanical truth about biological existence. Evolution engineers complex organisms to function as tuned biochemical engines, yet these engines possess strict, non-negotiable operating parameters. Pushing the external environment beyond these parameters does not result in violent, immediate destruction, but rather a quiet, progressive stalling of fundamental life processes. Animals resting in shaded canyons simply failed to wake as their internal chemistry decoupled under relentless atmospheric pressure. Revealing these microscopic thresholds showcases the astonishing depth of contemporary biological sciences, connecting ancient extinctions directly to fundamental thermodynamic principles. Expanding relentlessly across central plains and coastal margins, thermal dead zones eventually encompassed nearly all Pangaean territory. The vibrant, organized biological landscape characterizing the late Permian period slowly dissolved into a profound terrestrial stillness. Riverbeds that once channeled vital nutrients across diverse biomes now lay cracked and barren under a permanently hazy sky. Ambient sound itself changed across the supercontinent, transitioning from the complex acoustic web of a thriving ecosystem to the unbroken rush of dry winds sweeping over empty dunes. Documenting how the terrestrial realm emptied does not diminish the majesty of life, but rather emphasizes how planetary chemistry reigns supreme. Nature systematically cleared the continental slate, rendering millions of years of specialized biological investments mechanically obsolete in mere geological seconds. While the supercontinent absorbed this unprecedented thermal load and fell into a deep, mathematically defined silence, the immense planetary machine continued its relentless operation. Trapped solar energy possesses no preference for land or water. It merely seeks equilibrium across all available mediums. Billions of tons of heated air circulating above the barren terrestrial expanse began actively transferring their kinetic payload directly into Panthalas's surface layers. Covering over 70% of the globe, this colossal marine entity had previously functioned as the primary thermal buffer, quietly absorbing excess heat to maintain global stability. Subjecting this massive body of water to a continuous, uninterrupted supply of atmospheric energy initiated a completely new phase of the planetary rewrite. Fluid dynamics, dictating how ancient ocean currents moved, were about to face an unparalleled mechanical test, bridging the gap between scorched continental shores and the deepest, most inaccessible marine abysses. A plunge beneath the waves of Panthalassa reveals a planetary respiratory system operating on an unimaginable scale. Water does not merely rest passively within its global basin, it actively breathes. Surface layers constantly exchange gases with the air above, drawing down vital molecules through kinetic friction generated by wind and waves. Dissolved oxygen then travels downward, sustaining countless organisms dwelling miles below the sunlit zones. Marine biologists studying contemporary oceanic anatomy recognize this dynamic fluid exchange as a fundamental prerequisite for complex underwater biomes. Earth engineered its vast seas to function like a colossal lung, inhaling atmospheric gases and circulating them efficiently throughout the darkest abyssal trenches. Altering the thermal baseline of this immense liquid respiratory system triggers strict thermodynamic consequences. Basic physical laws dictate that liquid solvents lose their capacity to retain dissolved gases as their internal temperatures rise. Introducing massive quantities of atmospheric kinetic energy into the upper layers of Panthalassa forced water molecules into a highly agitated state. Rapidly vibrating microscopic particles effectively pushed essential oxygen out of suspension, releasing those life-giving elements directly back into the sky. Measuring this ancient thermal shift today requires paleoceanographers to extract microscopic conodont teeth from deep sedimentary layers. Analyzing distinct isotopes trapped securely within these fossilized enamel fragments grants humanity an incredibly precise thermometer. Such sophisticated forensic work proves definitively that sea surface temperatures surged well past modern equatorial maximums, turning vast stretches of the ocean into a chemically hostile medium. Retaining less oxygen at the surface only represented the initial phase of a much deeper fluid restructuring. Transporting whatever dissolved gases remained down to the ocean floor relied on a continuous mechanical engine driven by extreme temperature differentials. Marine water cooling near the freezing polar latitudes naturally contracts, becoming dense and physically heavy. Plunging downward with immense hydraulic force, these frigid currents historically carried rich loads of oxygen directly to the deep seabed before sweeping slowly along the ocean floor toward the equator. Rising heat from the atmospheric greenhouse anomaly directly targeted this precise mechanical vulnerability. Polar regions gradually lost their reflective ice shields to the warming sky and could no longer chill the surrounding surface waters sufficiently. Runoff from melting continental glaciers simultaneously flooded high-latitude seas with immense volumes of fresh water. Lacking the heavy salt content necessary to drive deep marine currents downward, this warmer, fresher surface layer remained stubbornly buoyant. Deprived of both intense cold and high salinity, the descending polar columns gradually lost their downward momentum. Modern supercomputers running highly complex fluid dynamic models allowed geophysicists to perfectly simulate this gradual hydraulic failure. Researchers virtually watch the mighty deep ocean currents steadily decelerate as their driving thermal engines systematically stall out across the upper latitudes. Complete mechanical arrest eventually settled over the global ocean. Panthalassa transitioned from a vigorously circulating fluid body into a profoundly stagnant expanse of water. Cut off from the heavy, cold currents plunging from the poles, the deep abyssal plains stopped receiving fresh oxygen supplies entirely. Water columns stratified strictly by temperature, locking warmer, lighter liquid permanently at the surface while denser, cooler waters sat trapped perfectly still at the bottom. The planetary lung simply ceased to inhale. Without vertical mixing, the marine depths transformed into heavily isolated zones disconnected from the atmosphere above. Exploring specific geological strata known as black shales provides contemporary humanity with indisputable chemical evidence of this immense stagnation. Finding these dark, finely laminated rocks devoid of burrowing trace fossils confirms that the ocean floor lay undisturbed by biological activity for thousands of centuries. Expanding dead zones pressed steadily upward from the deep trenches as the stagnation persisted. Anoxia, a condition defined by a total lack of dissolved oxygen, claimed the abyssal plains first before creeping relentlessly toward the continental shelves. Complex marine fauna inhabiting these lower depths possessed no evolutionary defenses against an invisible, systemic chemical depletion. Benthic organisms, ranging from intricate echinoderms to deep-water scavengers, slowly powered down as their cellular respiration engines failed entirely. Tracing this quiet biological phase-out highlights the incredible deductive power of modern geochemistry. Scientists map the boundaries of these ancient dead zones by measuring uranium and molybdenum isotopes preserved within the sediment. Such brilliant analytical techniques allow us to confidently reconstruct the geometrical spread of suffocating waters without ever needing a time machine. Mid-water ecosystems navigating the vast open columns faced an equally insurmountable physical barrier. Ammonites possessing mathematically perfect coiled shells relied on energetic jet propulsion to hunt and evade predators. Operating such advanced biomechanics requires massive biological fuel consumption, demanding constant access to highly oxygenated waters. As the anoxic boundary rose higher into the pelagic zones, these magnificent cephalopods found their habitable space violently compressed. Forced upward into steadily narrowing bands of breathable surface water, active species quickly exhausted their internal metabolic reserves. Paleontologists examining fossilized marine assemblages note a striking pattern where fast-moving, energetic organisms vanished significantly faster than sluggish, low-metabolism bottom dwellers. Biology remains eternally bound by the unforgiving calculus of energy expenditure and resource availability. Shallow marine environments along the coastlines initially seemed buffered from the creeping deep-sea anoxia, yet they ultimately succumbed to a different consequence of the global fluid arrest. Thriving reef ecosystems constructed by ancient sponges and diverse brachiopods depended entirely on strong ocean currents to deliver vital nutrients and sweep away cellular waste. When the massive planetary circulatory engine halted, these vibrant underwater cities lost their primary supply line. Nutrient upwelling ceased, leaving densely packed biological communities to starve quietly in perfectly clear, sunlit waters. We study these fossilized reef complexes today and marvel at their stunning structural complexity while fully understanding the invisible hydrodynamic failures that rendered them completely inert. Watching this marine transition unfold reveals an extinction event largely devoid of dramatic violence or chaotic struggle. Life across the vast stretches of Panthalassa simply faded away as the physical medium housing it lost its life-sustaining properties. Millions of specialized species spanning countless taxonomic orders went to sleep within a still fluid environment, documenting the disappearance of trilobites, a successful lineage that had continuously patrolled the ocean floor for nearly 300 million years, evokes a deep sense of scientific awe. These armored survivors had previously navigated multiple planetary crises with profound resilience. Their final departure from the fossil record during this specific chemical rewrite powerfully demonstrates that no amount of armored plating or evolutionary pedigree can outlast a fundamental shift in fluid chemistry. Exploring this silencing of the seas redefines our broader understanding of biological fragility. Oceans do not require violent storms, boiling temperatures, or massive physical impacts to dismantle enclosed ecosystems. Stripping away an invisible dissolved gas operates as a supremely efficient clearing mechanism. Human intellect peers through hundreds of millions of years of accumulated rock to fully grasp this subtle thermodynamic truth. We decode the exact physics of ancient water columns, proving our remarkable capacity to analyze global events unfolding on scales far larger than our own existence. Biological dominance meant nothing when the physical waters ceased to move. Stagnant, oxygen-depleted waters now stretched continuously from the deepest abyssal trenches to the sunlit shallows. Panthalassa had transformed into a still, unbreathable expanse, seemingly emptied of all significant biological ambition. Nature, however, absolutely abhors a true vacuum. While complex, oxygen-dependent organisms quietly vanished from the global stage, a different class of life form patiently waited in the microscopic shadows. Erasing the reigning marine hierarchy did not sterilize the oceans. It merely altered the foundational rules of survival. Deep within the undisturbed, heavily stratified waters, a new biological regime prepared to inherit the stagnant seas, ready to weaponize the very chemical environment that had just cleared the ancient world. Peering into this newly stratified abyss reveals not a desolate void, but a thriving, invisible metropolis operating on entirely different biological principles. Single-celled organisms known to modern science as anaerobic bacteria require no dissolved oxygen to fuel their cellular metabolism. To these specialized microscopic entities, the suffocating stillness enveloping Panthalassa represented an unprecedented evolutionary paradise. Unbound by the strict metabolic restrictions governing complex, multicellular animals, they rapidly colonized the dark, stagnant depths. Sinking organic matter cascading downward from the dying surface, ecosystems provided an almost limitless supply of raw nutritional fuel. Consuming this decaying material allowed these efficient life forms to multiply at rates that challenge human comprehension. Examining the profound adaptability of these simple cells forces us to expand our definition of biological success, demonstrating that life optimizes itself for whatever physical conditions the planet dictates. The reconstruction of this invisible biological explosion showcases the phenomenal deductive capabilities of contemporary microbiology. Researchers working in highly controlled modern laboratories routinely cultivate living strains. Observing their behavior under high-powered electron microscopes allows scientists to perfectly map the intricate biochemical reactions taking place within their microscopic cellular walls. Utilizing dissolved sulfates naturally present in ancient seawater, these remarkable microbes systematically broke down organic compounds through an efficient chemical process known as sulfate reduction. Extracting vital energy without utilizing oxygen represents a masterclass in elemental adaptation. Tracing the genetic lineage of these modern laboratory cultures directly back to the late Permian oceans stands as a monumental triumph, proving humanity can effectively read continuous biological histories spanning hundreds of millions of years. Operating without oxygen produces a radically different chemical output compared to standard animal respiration. Instead of exhaling carbon dioxide, these deep-sea cellular refiners generated immense volumes of hydrogen sulfide as a primary metabolic byproduct. To oxygen-breathing organisms, this reactive compound acts as a fast-acting, lethal neurotoxin. To the newly established microscopic hierarchy dominating Panthalassa, however, it simply represented the natural exhaust of a successful biological industry. Trillions upon trillions of microscopic entities continuously pumped this compound directly into the surrounding water column. Because the mighty thermohaline currents had stalled entirely, the newly synthesized gas possessed no physical mechanism for dispersal. It steadily pooled across the dark abyssal plains, gradually transforming the lowest ocean layers into a massive, undisturbed reservoir of dissolved chemical energy. Visualizing this immense transition requires us to look past the macroscopic animals and focus entirely on molecular chemistry. Panthalassa effectively stopped functioning as a traditional ocean and transformed into a planetary-scale biochemical reactor. Every passing century added billions of additional tons of hydrogen sulfide to the heavily stratified waters. Driven by sheer accumulation, the invisible boundary separating the toxic depths from the slightly more breathable upper layers began a relentless upward migration. Oceanographers call this deeply specific chemical transition zone the chemocline. Watching this barrier rise systematically through the water column illustrates the uncompromising nature of fluid dynamics. Physics dictates strictly that lighter, saturated fluids must displace the remaining clean water above them, rising steadily toward the sunlit surface. The immense hydrogen sulfide layer eventually intersected with the photic zone, reaching this shallow region where solar radiation still easily penetrated the waves, triggered a second, completely distinct biological bloom. Green sulfur bacteria, an entirely different class of specialized microbe, seized control of this specific chemical intersection. Thriving exclusively in environments combining pure, unfiltered sunlight with high concentrations of dissolved hydrogen sulfide, these organisms found their perfect habitat engineered for them. Multiplying exponentially across the upper pelagic zones, they initiated a massive structural rewrite of the ocean surface. They possessed unique photosynthetic pigments tuned to absorb specific wavelengths of light, allowing them to process the toxic gas into solid sulfur while synthesizing their vital cellular structures. Extracting absolute proof of this vibrant microscopic empire requires an analytical technique of staggering complexity. Paleoclimatologists today extract solid rock cores from deeply buried marine sediments and subject them to advanced liquid chromatography. Isolating microscopic fossilized lipid molecules hidden within the stone allows researchers to identify a highly specific biomarker known as isorenieretane. Producing this distinct molecular signature remains an exclusive trait of green sulfur bacteria. Discovering incredibly dense concentrations of isorenieretane securely locked within the late Permian sedimentary layers proves beyond any statistical doubt that these pigmented microbes completely dominated the ancient global ocean. Retrieving specific color palettes from solid rock that has sat undisturbed for 250 million years highlights the absolute pinnacle of human scientific investigation. We do not merely guess at the ancient conditions, we actively decode the exact organic compounds left behind by vanished cellular kingdoms. Shifting our perspective to the visual reality of this ancient ocean reveals a striking, deeply alien transformation. Populating the surface waters in astronomical numbers, the massive blooms of pigmented bacteria fundamentally altered the optical properties of Panthalassa. The pristine, transparent blue expanses characterizing the former marine environment shifted radically under the influence of these microscopic multitudes. Widespread coastal margins and vast stretches of the open sea adopted deep, cloudy hues of murky green and incredibly vibrant, striking purple. Witnessing this vast body of water glow with different spectral wavelengths underscores the profound power of single-celled organisms to physically reshape an entire planet. Life essentially painted the global ocean in a vibrant new chemical registry, perfectly reflecting the sweeping biochemical rewrite occurring just below the waves. Every single cubic meter of seawater now contained billions of highly active microbial refiners. The ocean waters thickened into a rich, heavily populated suspension of specialized organic matter. Marine fauna clinging desperately to the final, rapidly shrinking bands of oxygenated surface water found themselves completely surrounded by this advancing microbial tide. Advanced fishes and resilient ammonites possessed exceptionally refined anatomies, yet complex organs offered zero defensive capability against an environment shifting its fundamental molecular makeup. Biology honors sheer adaptability far more than complex neurological architecture. Animals requiring complex dissolved gases simply powered down as the heavily pigmented, sulfur-rich waters finally overtook their restricted habitats. Acknowledging this quiet biological phase-out inspires deep reverence for the impartial, unyielding mechanics of natural selection. Nature cleared the macroscopic hierarchy with profound efficiency, rewarding organisms that asked the least from their rapidly changing environment. Mapping this staggering transition from complex marine ecosystems to a globally unified microbial soup emphasizes the sheer interconnectedness of planetary elements. Geologists trace exactly how carbon molecules forcefully injected into the sky directly stalled the deep ocean currents, which subsequently created the perfect chemical incubator for microscopic bacterial multiplication. Recognizing these vast, interlocking feedback loops showcases human intellect operating at its highest capacity. We possess the unique ability to stand completely outside the timeline, analyzing billions of years of planetary history to perfectly understand how distinct atmospheric variables translate directly into biological realities. Humanity visualizes these ancient oceans not as a scene of despair, but as a spectacularly efficient chemical transition where one dominant state of matter seamlessly replaced another. Pressure within this massive liquid environment eventually began building toward an absolute physical threshold. Water possesses strict mathematical limits regarding how much gas it can hold in a dissolved state. Trillions of microscopic microbes continued to consume sinking organic material, endlessly churning out unfathomable volumes of hydrogen sulfide. Saturated beyond standard physical capacities, the upper layers of the ocean could no longer safely contain the immense chemical payload generated by this biological industry. Dissolved compounds began actively seeking an escape route, migrating steadily toward the absolute uppermost boundary, where the heavy liquid meets the open air. The global ocean had successfully completed its transition into an immense pressurized chemical weapon, silently preparing to transfer its lethal microscopic harvest directly back into the atmosphere that had originally triggered its stagnation. Breaking the physical surface tension required only a microscopic shift in the mechanics of fluid dynamics. Highly saturated upper marine layers could no longer safely contain their immense dissolved payload. Countless microscopic bubbles carrying concentrated hydrogen sulfide breached the oceanic surface, initiating a colossal gaseous transfer from the hydrosphere directly back into the open sky. Releasing this compound operated entirely on strict principles governing partial pressure and molecular diffusion. High-energy molecules naturally migrated toward areas of lower atmospheric concentration, pushing relentlessly upward into the lower troposphere. Trillions of tons of highly reactive gas flooded the lower wind currents over extremely brief geological windows. Updrafts carried this volatile payload high above the barren continents, fundamentally altering how incoming solar radiation interacted with the gaseous envelope surrounding the Earth. Incoming photons traveling from the Sun suddenly encountered an entirely different chemical filter. Atmospheric optics dictate the visual reality we perceive above our heads, relying strictly on the precise atomic geometry of airborne molecules to scatter incoming light. Standard planetary compositions primarily scatter shorter blue wavelengths, generating the familiar azure dome we recognize today. Saturating the troposphere with dense sulfur-based compounds drastically modified this foundational optical phenomenon. Altered spectral dynamics forced the sky to interact with distinct, specific wavelengths, actively absorbing blue light while heavily refracting deeper, richer hues. Anyone standing on the terrestrial plains would look up to witness the atmosphere transition into an intense, vibrant purple. Human intellect continuously marvels at our profound ability to deduce the visual spectrum of an era we will never directly observe. Contemporary astrophysicists apply rigorous spectroscopic models to ancient gas ratios extracted from deep rock cores, calculating how prehistoric photons bounced through a fundamentally altered medium. Thermal currents eventually carried these rising reactive molecules far beyond the visible cloud layers. Upon reaching the stratosphere, the hydrogen sulfide encountered a delicate, energetic chemical barrier actively protecting the biosphere below. Positioned tens of miles above the terrestrial surface, ozone exists simply as three oxygen atoms temporarily bound together by intense solar energy. This thin molecular layer operates as a critical planetary shield, absorbing dangerous high-frequency ultraviolet radiation before those cosmic rays can reach the ground. The injection of massive quantities of sulfur and newly liberated halogen gases into this high-altitude zone triggered a rapid, systematic unraveling of these crucial atomic bonds. Chemical reactions operating high in the upper atmosphere stripped the ozone molecules apart significantly faster than incoming solar energy could rebuild them. Highly reactive radicals acted as hyper-efficient catalytic agents, systematically tearing single oxygen atoms away from the protective structures and leaving behind ordinary, transparent, diatomic oxygen. Removing this molecular armor effectively opened the planetary window to unfiltered cosmic kinetic energy. Documenting this invisible stratospheric collapse requires modern researchers to utilize brilliantly sophisticated analytical frameworks. Paleobiologists successfully isolate specific fossilized spores extracted directly from ancient terrestrial rockbeds, searching exclusively for definitive microscopic evidence of severe environmental stress. Discovering distinct malformations in these tiny biological structures grants humanity indisputable proof that an invisible, high-altitude shield had completely failed. Unfiltered ultraviolet B radiation plunged downward through the compromised atmosphere, striking terrestrial and shallow marine environments with terrifying, unmitigated kinetic force. Living tissue possesses remarkable evolutionary resilience, yet it remains fundamentally vulnerable to specific frequencies of electromagnetic light. High-energy photons operate essentially as microscopic projectiles, actively penetrating biological cells and forcefully breaking the delicate hydrogen bonds holding DNA strands together. When extreme ultraviolet radiation strikes a living organism lacking an atmospheric filter, it causes neighboring thymine bases within the genetic code to fuse incorrectly. Such extreme disruption of life's fundamental blueprint ensures that cellular replication either stalls completely or produces catastrophic biological errors. Botanists studying fossilized pollen grains from the late Permian observe this massive genetic scrambling preserved perfectly in solid stone. Carefully unearthing dense clusters of mutated plant spores reveals complex structures deeply scarred by localized tissue necrosis and severe developmental failures. Vegetation already desperately stressed by extreme equatorial heat and rampant planetary dehydration now faced an inescapable barrage of cellular degradation. Fronds and leaves simply scorched under the invisible celestial bombardment, losing their ability to photosynthesize entirely. Through advanced scanning electron microscopes, scientists actively peer at warped cellular walls and instantly connect a twisted microscopic spore to a vanished atmospheric shield located tens of miles above the ancient ground. We understand exactly how high-altitude physics systematically dismantled terrestrial biology at the most fundamental molecular level. By directly mixing with atmospheric water vapor, high-altitude sulfur compounds rapidly underwent intense oxidation, generating yet another cascading planetary mechanism. These oxidized molecules naturally synthesized heavy concentrations of sulfuric and carbonic acid high above the supercontinent. Condensation processes driven by extreme global heat gathered these corrosive liquids into massive, sprawling cloud formations. Intense atmospheric circulation systems subsequently dragged these dense chemical storm fronts across the shifting terrestrial land masses. Precipitation falling from the vibrant, heavily altered sky no longer delivered life-sustaining, neutral moisture. Liquid droplets cascading onto the plains carried a pH level low enough to aggressively dissolve organic tissue and rapidly weather solid stone. Massive deluges of acidic rain poured relentlessly across the shifting topography, initiating an unprecedented physical sculpting of the entire supercontinent. Exposed limestone formations and dense silicate structures encountered a remarkably efficient, endlessly replenishing chemical solvent. Geological surveys meticulously mapping deep global stratigraphy reveal entire terrestrial layers suddenly stripped of complex mineral soils. Analyzing these eroded boundaries clearly shows humanity how swiftly a chemically active atmosphere can dissolve the rigid crust of the planet. Groundwaters saturated with concentrated acids rapidly sterilized subterranean networks, preventing struggling root systems from drawing any viable nutrients. Extensive broadleaf forests dissolved into vast swaths of decaying organic matter, further accelerating the immense release of stored carbon into the increasingly saturated, darkening sky. A drastically lowered pH at the ocean surface fundamentally altered the saturation state of calcium carbonate along the global coastlines. Countless marine organisms, ranging from intricate brachiopods to massive reef-building sponges, relied entirely on this vital mineral to construct their protective shells and skeletal frameworks. Introducing highly acidic runoff into these delicate coastal habitats effectively reversed the biological calcification process. Living creatures actively dissolving within their own fluid environments illustrates the uncompromising supremacy of elemental chemistry over biological ambition. Organic engineering simply cannot maintain physical integrity when the surrounding fluid actively targets and breaks down the foundational minerals required for basic cellular survival. Interpreting the blank spaces within the rock record demands an astonishing level of intellectual rigor. Researchers actively examining ancient limestone deposits document a sudden, catastrophic absence of calcified fossils precisely at this specific geological junction. We recognize this sheer biological void not as a mysterious disappearance, but as a meticulously calculated chemical equation playing out across a planetary scale. Nature effectively erased massive biological structures by simply tweaking the pH balance of the fluid medium enclosing them. Mapping the exact geochemical boundaries of this dissolution event highlights our exceptional capacity to decode the most complex natural algorithms ever executed on Earth. Watching this grand, interconnected thermodynamic sequence reach its peak fills the scientific mind with a profound sense of awe. Every distinct planetary system participated in a flawlessly synchronized transition, linking the deepest subterranean depths directly to the highest atmospheric layers. Magma initially triggered ancient carbon. Carbon efficiently trapped solar heat. Heat mechanically stalled the vast seas. Stagnant seas actively bred highly specialized toxic bacteria, and bacterial gas systematically dismantled the protective sky. To understand this massive chain reaction requires humanity to completely transcend our brief temporal existence and think dynamically in deep geological time. This staggering sequence of events did not unfold out of chaotic malice, but operated purely as an impartial, magnificent demonstration of fundamental physical laws redefining the chemical operating system of an entire world. Terrestrial landscapes now lay stripped of their complex floral architecture, actively dissolving under relentless chemical storms. Shallow marine shelves, previously housing the most vibrant, diverse ecosystems on the planet, transformed into acidic, barren coastal zones. Only the most adaptable, deeply resilient organisms clinging to the fringes of habitability remained functional. Life had been pushed to the extreme margins of biological possibility, enduring an environment actively hostile to complex cellular mechanics. Yet, even as the atmospheric chemistry reached its most lethal concentration, the planetary engine slowly prepared to execute its final, defining maneuver. The global temperature and saturated atmosphere were rapidly approaching a mathematical equilibrium, signaling the end of the violent transition and the beginning of a profoundly silent, fundamentally altered new epoch. Reaching this unprecedented thermodynamic balance rendered the once bustling supercontinent motionless. Wind currents sweeping across Pangaea no longer carried the complex vocalizations of massive predators or the heavy footfalls of migrating herds. Deep geological silence settled over the entire landmass, matching the profound stillness characterizing the newly stratified oceans. Assessing the fossil record at this precise boundary reveals a staggering statistical reality where roughly 90% of all living species simply ceased to exist. We often instinctively categorize such massive biological depletion as a profound tragedy, mourning the magnificent anatomical forms that vanished forever into the rock layers. Looking at this transition through the rigorous, objective lens of planetary mechanics offers a fundamentally different perspective. Biological organisms ultimately represent temporary physical configurations of matter, dependent on specific external parameters to function. When those external environmental parameters shifted rapidly, the previously established living configurations naturally dissolved, leaving behind a vast, unpopulated terrain, completely devoid of deeply entrenched ecological monopolies. Viewing this emptied landscape requires humanity to fully appreciate how highly optimized natural systems inherently restrict future innovation. Prior to the intense subterranean anomalies in Siberia, deep evolutionary pathways had become entirely gridlocked. Dominant synapsids and massive gorgonopsians occupied every available macroscopic niche, efficiently suppressing any radically different biological architectures from gaining a terrestrial foothold. Maintaining that perfectly balanced ancient ecosystem practically guaranteed that terrestrial life would remain biologically stagnant for future eons. Dismantling this powerful, deeply established hierarchy therefore operated as a mechanical necessity for eventual global diversification. Extreme environmental stress effectively wiped the planetary slate clean, forcefully removing the biological heavyweights that had exclusively consumed immense planetary resources for countless millennia. Surviving this rigorous chemical filter demanded unspecialized adaptability rather than raw physical dominance or intricate genetic specialization. Buried within this seemingly barren aftermath lay the microscopic and subterranean seeds of an entirely new biological paradigm. Small, resilient creatures managed to endure the extreme thermal and acidic stresses by retreating deep underground or clinging to isolated, shaded refuges. Among these unassuming survivors were the resilient archosaurs, small, fast-moving reptiles possessing distinct biological advantages, exhibiting remarkably efficient respiratory systems capable of extracting oxygen from a heavily depleted atmosphere. These slender reptiles found themselves suddenly inheriting an unimaginably expansive territory. Without towering predators to hunt them or massive herbivores to outcompete them for sparse vegetation, these agile organisms rapidly expanded outward across the recovering landmass. Taking full advantage of the newly cleared ecological slate, they initiated an explosive evolutionary radiation that would eventually conquer the entire globe, completely defining the magnificent Mesozoic era and birthing the dinosaurs. Simultaneously, an even more profound evolutionary narrative was quietly unfolding in the darkest corners of this newly stabilized world. Cynodonts, a marginalized lineage of small, burrowing proto-mammals, successfully navigated the extreme environmental transition by radically altering their fundamental biological engineering. Forced to hunt insects and scavenge entirely at night to avoid the punishing residual daytime heat, these remarkable creatures gradually developed highly insulated fur and warm-blooded metabolic engines. Navigating complex nocturnal environments demanded significantly enhanced sensory processing, driving a steady, unprecedented expansion of the cerebral cortex. Paleontologists, meticulously examining crushed cynodont skulls, perfectly trace the exact anatomical modifications occurring during this era, specifically noting how ancient jawbones systematically migrated backward to eventually form the complex inner ear structures required for advanced mammalian hearing. We trace our own deepest genetic heritage directly back to these small, trembling survivors operating entirely in the planetary shadows. Humanity owes its very existence to this precise geological juncture. Had the Permian world never encountered its invisible chemical restructuring, massive archaic reptiles would have indefinitely suppressed mammalian development, permanently preventing the eventual rise of conscious, analytical human intellect. Recognizing this profound existential pivot showcases the pinnacle of our modern cognitive capability. We possess the unique, spectacular ability to look back across hundreds of millions of years and understand how seemingly catastrophic destruction serves as the primary catalyst for boundless biological innovation. No other creature in the known history of the universe has ever managed to actively read the complex geological history written in the rocks beneath its feet. Through sheer deductive reasoning and rigorous technological application, modern scientists connect ancient atmospheric anomalies directly to the structural development of the human brain. We stand upon the modern Earth not as accidental tourists, but as the highly evolved products of an uncompromising planetary forge. Human intelligence represents the cosmos slowly waking up to recognize and measure its own intricate, vast developmental history. Gathering precise atmospheric data today brings this ancient narrative completely full circle. High atop volcanic peaks in Hawaii and deep within isolated Antarctic research stations, contemporary climatologists continuously monitor the exact same invisible chemical variables that once dismantled Pangaea. Measuring modern carbon dioxide concentrations in parts per million reveals a steeply accelerating curve mirroring the mathematical models of the deep past with astonishing precision. Advanced mass spectrometers actively analyzing these contemporary air samples detect specific isotopic signatures floating invisibly around us. Fossil fuels continuously burning inside modern industrial engines release vast quantities of carbon-12 directly into the open sky, artificially recreating the precise molecular flood once triggered by the deep subterranean fires in Siberia. Tracing this undeniable isotopic ratio proves definitively that humanity is currently manipulating the exact same thermodynamic levers that govern deep-time extinction cycles. Quantifying the rate of this modern elemental transfer highlights a genuinely unprecedented physical reality. Magma pushing relentlessly through the ancient crust released astronomical volumes of greenhouse gases over a timeline stretching across tens of thousands of years. Contemporary industrial civilization currently injects similar molecular compounds into the atmosphere at a velocity significantly exceeding that ancient geological mechanism. Releasing tightly locked terrestrial carbon at such an aggressive pace severely compresses the critical time frame available for the biosphere to execute necessary evolutionary adjustment. High-altitude satellites currently orbiting our planet constantly measure the amount of outgoing long-wave infrared radiation escaping into space. Correlating this real-time satellite data with ground-based temperature nodes proves absolutely that adding heat-trapping molecules to an enclosed atmosphere must inevitably increase localized kinetic energy and forcefully alter global fluid dynamics, completely regardless of whether a conscious biological entity or a blind volcanic fissure initiated the chemical sequence. Understanding this perfectly impartial elemental truth delivers a stark, mathematically sound realization about our modern world. Earth possesses no inherent loyalty to its current biological configuration or any preference for the survival of human civilization. The mighty ocean currents will simply stall again if their driving thermal engines are pushed violently past strict thermodynamic thresholds. Stratospheric shields will eventually thin if actively bombarded by sufficient reactive industrial compounds. Nature merely balances its complex chemical ledgers using whatever raw materials are presently available in the active planetary system. When crucial environmental variables shift too rapidly, the planet efficiently clears away outdated organic architectures to establish a fundamentally new mathematical equilibrium. Surviving such massive transitions relies entirely on adhering strictly to the unforgiving, absolute laws governing atmospheric physics and planetary thermodynamics. Confronting this modern atmospheric reality does not require us to passively accept a predefined geological fate. Unlike the magnificently specialized apex predators that perished blindly on the shifting Permian plains, humanity possesses a profoundly powerful evolutionary advantage. We are fully aware of the underlying chemical equations dictating our future. Armed with advanced supercomputers, deep-sea submersibles, and complex orbital sensors, our species actively monitors the planetary pulse in real time. We hold the astonishing biological capability to project future climate states, perfectly model complex fluid dynamics, and deliberately alter our own behavior to maintain optimal global stability. Transcending basic survival instincts, the human mind successfully decodes the fundamental operating system of the entire world. Utilizing this majestic intellectual power allows us to steer our collective future safely away from invisible thermodynamic thresholds, powerfully proving that highly conscious, data-driven adaptation represents the triumph of life over impartial planetary mechanics.